hi, fourth grade. I was just drawing a picture. Why? Well, maybe because our problem-solving strategy today is drawing a picture. What was I drawing? Oh, I was just drawing a balloon that says, "Happy birthday, Caleb." It's Caleb's birthday today. Make sure you say happy birthday once we're on our Zoom. All right, so before we jump into our draw a picture problem-solving strategy, I want to say thank you for all of you that had part in the teacher video on Friday. That was awesome. And I also got some letters. I got a letter in the mail. Thank you, Jack. And I got some other letters on text and email, which was awesome. Thank you if that was you. And I appreciate it. And I know the other teachers appreciated it also. So, drawing a picture. I know a lot of you like to draw pictures. You like to draw, especially during math. So this is perfect. So I need you to turn to page 512. And it says problem solving strategy on the top. And today's problem solving strategy is drawing a picture. All right, so if you are on page 512, on the top it says draw a picture. How do you draw a picture to solve a problem? And this is the problem that we're going to talk about right now. Race markers. A 5-kilometer run had markers at the starting line and the finish line. Markers were also placed at each kilometer. How many markers were used for the race? All right, well, you could do that in your head, but you might mess up. So the easier thing to do would be to draw a picture. So we know that there is the starting line. There's a marker at the starting line. And we know that there's a finishing line. And there's the starting line. And there's the finishing line. And it says that the race is 5 kilometers. So the finishing line is going to be 5 kilometers at the finish, 0 at the start, because they haven't run any at the start. So then it says that there is another marker every kilometer, okay? So we're going to go from 0 to 1 and make a marker, 1 to 2, make a marker, 2 to 3, make a marker, 3 to 4, make a marker, and the end is 5, okay? So we have 1, 2, 3, 4, 5, 6 markers. So the answer would be that you have 6 markers total. Now, why would you not just say, oh, there's this many markers? Well, sometimes it can be confusing because it's a 5-kilometer race. So you would think, oh, there's 5 markers because it's 5 kilometers. But we also have a marker at the starting line, which is at 0. So that's how we ended up with 6 markers. Okay, now you probably could have figured that out in your head, but drawing a picture, because the problems aren't always this easy, drawing a picture makes it easier for you to visualize it and see what you are doing. Okay, so let's talk about it. Number 1, it says Zach said the answer was 4 markers. What did he forget to do? I'm thinking that he forgot to do count the start and finish. Okay, so let's look at check on page 513. It says solve the problem. Write the answer in a complete sentence. Sharing sandwiches. Sean, Heidi, and Missy want to share 2 1-foot-long sandwiches. Okay, so I'm gonna draw 2 foot-long sandwiches. We would call those grinders in Rhode Island. Do you call them grinders in Massachusetts? I don't know, because I don't live in Massachusetts. All right, so they want to share 2 1-foot-long sandwiches equally. Okay, how much should each 3 friends get? Okay, so I think since there are 3 friends, we need to divide these sandwiches into thirds. Okay. Okay, I'm thinking that the middle person's gonna want those. Okay, so if you divide those 2 sandwiches into thirds, okay, how many thirds is each person going to get? Okay, each person is going to get, so each sandwich is a foot long, right? Okay, so 12 inches long. Sometimes they're not actually 12 inches, but we're gonna pretend that this time they actually are 12 inches. Okay, this is 12 inches, this is 12 inches. Okay, so if you divide each sandwich into 3, how many inches are in each piece if you divide them equally? 4 inches. Okay, 4 inches. All right, so each friend, since there's 3 friends, each friend, so this is your complete sentence, each friend will get 2 4-inch sandwiches. Now, why wouldn't they just each get 8 inches? Because you can't divide a 12-inch into 2 8-inches. You could do an 8-inch piece for one friend, and then an 8-inch piece for another friend, and then 2 4-inches for the third friend, but it asks you to do it equally, okay? So each friend will get 2 4-inch sandwiches, all right? Okay, so drawing a picture makes it easier to understand. All right, so for your homework for tonight, you are going to do page 513, practice odd. 513, practice odd. Okay, so it would be 3, 5, and 7. You have 3 problems to do. Not bad. All right, so let's see what you're doing tomorrow or later today if you're ambitious. Okay, for tomorrow, we're going to go to page 516, and we're going to talk about equivalent fractions. Equivalent fractions. If you remember earlier in the year, equivalent is a long fancy name for equal to, or means the same amount. Okay, so I'm gonna grab my tiles. All right. Wow, that was a lot of dropping of things. Okay, using our tiles, we can see what some equivalent fractions would be. For instance, I have 1/2 right here. Well, 1/2 is equivalent to 2/4. Okay, if I have 1/2 of an object, so this is the whole object. Let's say this is a very long and skinny candy bar, and I have 1/2. I keep dropping stuff. If I have 1/2 of the candy bar, and let's say I want to divide it between 2 people, the half, it is the same as 2/4. Okay, so equivalent fractions are fractions that show the same amount. Okay, now one thing that you need to know about equivalent fractions, so let's say I have 1/2 equals 2/4. Okay, whenever you are making a fraction equivalent, you have to do the same thing to the top that you do to the bottom. So look at this. 1 times 2 equals 2. 2 times 2 equals 4. Okay, so 1/2 is equal to 2/4. It takes up the same amount. Okay, so that would mean that it's also equal to 4/8, and so on. Okay, because look, 1 times 4 is 4. 2 times 4 is 8. Okay, it could also be 1/2 could also equal 250 over 500. Okay, if I have 500 pieces and something broken into 500 pieces and I take 250 of them, it's 1/2 of it. Look, 1 times 250 is 250. 2 times 250 is 500. So as long as you do the same thing to the top as to the bottom, it is equivalent. So look at this talking about using fraction tiles, okay? If you look at 5/16, you have number 1, you have the whole. Look, it's divided into 2 halves. Okay, but then if you look down, you have 2/4 is the same as 1/2. It takes up the same amount. Okay, 3/6 takes up the same amount as 1/2, so that's the equivalent. 4/8, 5/10, 6/12. They all are equivalent to 1/2 because they take up the same amount. They are equal to the same amount, just broken up into smaller pieces. Okay, so let's say you have a pizza. You have a pizza. You have 2 pizzas. And you cut one pizza. You cut one pizza into 6 pieces. And you cut the other pizza into 2 pieces. Okay, and then you eat half of this pizza. You have 1/2 left. Okay, and you eat half of this pizza. You have 3 pieces left because you divided this one into 6. Okay, so 3/6 is the same as 1/2. Okay, it doesn't make more pizza. Okay, they're just smaller pieces. All right, so 1/2 is equivalent to 3/6 as long as it takes up the same amount. Now, if those pizzas were different sizes, that would be a different story. Okay, so for today, or tomorrow, for your homework, you are going to do 518A odd. 518A odd. All right? All right. I will see you in a few minutes.